my history goes back to in open source ERP anyway. It kind of started with an opportunity to work at an e-commerce startup that was just getting going and being run by the older brother of one of the guys I grew up with. So at the time I was working for a company that did embedded Linux distributions and some software for embedded Linux devices. So the main thing I was working on was a web browser for desktop boxes, which was kind of interesting, seeing some of the internals of a browser. Not that it was anything like modern browsers that are available open source and such, but kind of an interesting thing to work on. Then getting into this e-commerce startup, a big thing.
Or, by the way, what year was that, just approximately?
So that was right around 2000. So this is the era of the NASDAQ stock bubble where everything was looking really rosy. With this e-commerce startup, they got funding pretty easily, but then about a year in, as we started getting things more settled in terms of what we do with technology and all that kind of stuff, the funding environment had changed. So partly from that and partly from seeing some difficulty and a lot of expense with trying to put together what we wanted to using the commercial software of the day, they decided to, well, commercial or open source, but really there were not a whole lot of open source options. They decided to just cancel the company, return what remained of the investment funds, and that was it. So that was an interesting example of how super expensive software, or maybe better to look at it the other way around, inexpensive software, easily accessible software like open source software can very much make a difference in whether a company can do something or not, whether their budget will be adequate to do what they want to do. And that is something that comes up a lot in software projects. So that was right around 2000, 2001. And then in 2001, so after that, I was working for another little software startup. And at one point, they actually decided to go the open source route, but the software that we had built was fairly basic. They also ran out of money. So this is kind of a theme for that era of kind of a downturn in the stock market, especially in technology in those years. But they also ran out of money, and they asked me to keep on working without getting paid. And I thought, well, if I'm going to keep on working without getting paid, I'm going to work on my own open source project. I've got some ideas for something a bit different. And that was really the genesis of OFBiz. So yeah, so those are the main projects I'm known for. The main projects I've worked on over time is OFBiz and then the Moqui projects, and some things related to those, but that's been the main focus. So my history with them is starting the projects and then kind of putting in initial legwork. I did a lot more building of community with OFBiz than I have with Moqui. With Moqui, I put the emphasis more on just the software and didn't put as much time into building the community. And you can kind of see that with the result of it, but also wanted a higher bar for quality in Moqui than was in OFBiz, because that was a constant and ongoing problem. Not just the difficulty of deciding on what the software should do, but actually having software that reliably does it was a big difficulty there. So anyway, yeah. So there's a little history and whatnot.
Awesome, thanks. It's interesting, your history, and I imagine that you've spent a lot of time thinking about creating an application like this. And so I'd like to get your interpretation on what a database is and what its function is.
Sure. So the general concept of a database, or you could call it a data store just as well, is a place to put your data, and that can have varying levels of structure. So even an operating system has, data store abilities with a file system and files, and databases kind of work in a little bit different domain, where the data is significantly more structured. And that's kind of the main feature of it. So whether you have a relational or tabular database, relation being kind of an old word for a kind of a tuple-based structure where you have, or a row and column structure. So those are, one way of organizing data. And then there are modern databases that use like machine readable documents, like JSON documents or XML documents, and store data in those, which has some advantages for flexibility of structure. You don't have the strict columns idea and that sort of thing. There are lots of things you can do in a relational database to have more flexible data structures in it, like row-based and like name value pair kind of tables as opposed to column-based. But in general, there's some fundamental differences between something like a document database, where each record is a document, and a relational database where where each record is a tuple of values, one value for each column in the table. So that's kind of the main thing about databases. Is they have a way to structure data that makes it either easier for machine readability or for doing things with particular bits of the data and ignoring others, like doing column-based queries and such, or column value-based queries, I should say. So the database is really all about that, basically storing data, retrieving it efficiently, and with certain types of databases, even more advanced operations, like looking at combinations of data and not just individual bits of it, or combining data to create different sets of data. And then I guess focusing on relational databases, and that's what the OFViz Entity Engine and the Moqui Entity Facade are about, is specifically relational databases, so tabular ones. So they have a lot of benefits to them. One of the big ones is simplicity. Like anyone who's used a spreadsheet kind of has the general idea of what a table structure is like. And there's a lot of, or it's very easy for humans to get in and look at a lot of data in a tabular structure. And then as people get more used to using it, the ideas of value in one table referring to a key of another, so that you can have other data related to the current data you're looking at, a lot of those sort of concepts come fairly easily. So it's historically been a good pattern for splitting up and structuring data, especially for business applications, and because of that, there's an incredible amount of infrastructure and know-how, tooling, and so on around this, and pretty amazing algorithms and indexing and so on that make, especially modern database software, incredibly efficient, and able to scale databases up to billions of records, sort of thing, even with kind of mortal hardware. So yeah, so there's a little bit about history of databases, and or the general idea of databases, and what we'd use them for, and kind of the distinction between that, a couple of different types of databases. And of course, there are other types like graph databases and object databases and so on that people have experimented with a lot. But even with a lot of those, over time, just the ability to do mass manipulation of data, ability to move data between systems, and to easily understand data and how it's structured and so on, There just is no other, especially for business applications, and many things that kind of fit the wider definition of enterprise applications, or say a more like generous definition there. The relational databases are just unmatched. So they've been the foundation of an incredible amount of technology, and are incredible technology themselves.
Right. It's incredible how often databases are used. What's a little bit about how the relational database handles transactions, and how you, like, the general practice of how you interact with a relational database?
Yeah, transactions are interesting when you get into managing data, because data is not as useful if only one person can, or one thread on a system can touch it at a time. But then you have problems with when you do start having more than one person able to touch it at a time, or more than one thread on a system, which could be a single physical system or distributed across a bunch of physical hardware, is concurrency. So when you're looking at data, in a lot of cases, when you're reading data from the database, you need to be sure that no one else is changing that data while you're working on it. So like you're updating I guess a classic example that's fairly easy, but there are lots of others. And even in the Moqui ecosystem, like where these are actually built out, let's do the inventory one. So another one is like the balance in a bank account. That's very common. But inventory one, if you want strict management of inventory levels and inventory availability, then there's this question of how much is left. And say you're on a busy shopping day, which coincide with holidays a lot, and you're getting just an incredible number of orders coming in, including a lot of orders for the same products. And if you want to make sure that you don't overcommit on your orders, like telling customers that it's available when it's really not, then you have a problem of multiple threads or multiple users needing to both look at and modify data at the same pool of data at the same time. So transactions will basically help with guaranteeing certain things about the data. So there are other ways to do it, but the simplest way to think about transactions and data protection is the locking mechanism. Most databases don't use locks in the way you traditionally think about them. They use some more advanced approaches for this, like multi-version currency control, copy on write types of schemes, and things like that. But the general idea with locking is that if I have a lock on a record, then no one else can read or write to it, or others can read from it, but what they will read is only the previously committed value. And then I want some ability to say that I'm looking at this, so anyone else who wants to look at it and really cares about the value, being the latest up-to-date value, should also respect those locks. So if it's locked, they should wait for the lock to clear until they even read it. So a few things like that can be kind of combined together to make code that can safely update something like an inventory level without worrying about conflicting with other users or threads. And typically the simple algorithm is something like lock a record, and in that single operation, if someone else has a lock on it, then these are typically exclusive locks. then so only one person can hold the exclusive lock at a time, or one thread. So basically lock a record as you query it. So you're telling the database to not even return the data until it can get a lock on it for exclusive access. Do what's needed to update the data, and write it back. Once the transaction is committed, then once those changes in the transaction are committed, then another transaction can pick up the lock and see the updated value and make their own. So there are some cases where you don't need locks to get reliable results. Like with inventory levels or an account balance, if all operations were incremental instead of setting a value, then you can avoid the need for certain types of locks. So, and that's an approach for much better concurrency, but most relational databases don't support that. There are some databases that are kind of built around that idea, providing a higher level of concurrency by limiting the operations you can do on numbers. And to some extent, you can design things in relational databases to do only those sorts of incremental operations, but there's not as much you can do. So the classic thing is basically the classic approach is using locks, and then it's up to the database to figure out how to do that efficiently, and modern databases do that quite well. So that's one big example of where transactions are important. But of course there are others, like just for convenience when writing software. It's very common that you're doing a single operation that involves updating data across multiple records and multiple columns in those records. So you want all of that to happen all at once as a set, or not happen at all. And if something fails, it's nice to have a rollback mechanism where basically you can say, just undo everything I've done as part of this transaction, instead of writing code that manually goes back and unrolls things. And databases handle this in a much cleaner way, and there are even other things in Moqui that use this sort of similar concept, like the context stack, where things are written to a separate place for a particular transaction, either in memory or on disk. It's up to the database to decide as needed. But data is written to a separate place until a transaction is committed. And then if you want to roll back the transaction, it just removes the data from that place. It doesn't have to change anything else. So so that's another great convenience of transactions, is that set of data changes happening all at once, or as a set.
So if I understand correctly, what a relational database is and how it manages transactions is it always makes sure that the data that is stored, whatever that data is, for lots of people who are accessing it, which gets complicated, but that for every person that is accessing that data or reading it, so accessing it is reading it, but that or creating or updating that data is the same across all of these different places, and making sure that that is the case. Like when it says that the data is there, the data actually is there.
Right. Yeah. Like the consistency, the consistency concept. Yeah.
I can see how that's helpful in business applications.
Right. And in theory, you could write transactional business applications without this sort of underlying technology, but it's a lot more difficult. Like for every routine you write, you could write some way that modifies data. You could write something that keeps track of your own changes, the original state, and undoes them. You'd just be sacrificing a great deal of convenience, and a better way to do it than trying to track your own changes. in a way that you can undo them at any time. So, but
Right.
there certainly, like, you can hand roll any of this stuff, and even locking and such. There are other ways to do it, or like incremental algorithms. Um, well, actually, one interesting example of that where um, it's not it's not how it works so much anymore. Like the Moqui Entity Facade uses a lock in the database for um, or it locks it like for update queries, using that kind of lock in the database for sequenced IDs. Um, But the original implementation in the OFVIS entity engine actually tried to use a collision detection sort of approach. So it would do an incremental operation, then do another query to make sure that after the incremental operation, it was the value expected. And if it wasn't, then it had a collision, and it would throw it away and try again. So that there's something, so there's a lot of things like that you can do that don't require locks, but things like locks are incredibly convenient. So yeah.
What is some of the so you said that there are other ways to approach a database. What are some of the and you've kind of talked about the advantages and disadvantages of a relational database, but what are some of the other ways to approach a database, and what are some of the problems with them, and
In
some of the good parts of them?
like general data stores, or do you mean like more specifically relational versus like a document or graph database, or these sorts of things?
Well, I mean, just the philosophy of like less the data types of how they're stored, but more the philosophy of a um, relational database versus which is kind of like the traditional SQL model
Hmm.
versus the not necessarily SQL model.
Or like the no SQL that often ends up adding some SQL looking thing.
Yes, exactly.
Um, so I guess no SQL really is just a term that kind of means we'll be flexible about the definition of the database. 'Cause even with SQL, there's a lot you can do on a document database. Document databases often don't have things like foreign keys, or the ability to do a joined query, like a join across multiple documents. Um, they rely instead more on other indexing and searching and kind of different data model patterns because of that. So quick access by a key is kind of the main model they go on, or a general search using those types of things, as opposed to relational database where you can look across multiple tables much more efficiently. Um, and in theory, document databases could do those things. It's just not a common feature in them. But a lot of it really just comes down, like the differences really just come down to how the data is structured underneath. So a database being a general tool for managing, like for storing and querying, and, or searching structured data is you can structure the data in all sorts of different ways. I mean, there are tree databases. They're like and as sort of a subset of graph databases, but they're optimized, and their indexes are all optimized around trees. And then graph databases, of course, they focus a lot on being able to follow connections between nodes in the graph very efficiently, and so they kind of model things differently underneath. Um, so a lot of it comes down to basic data structures, and then how to build a system that can handle a lot of those data structures. Um, be it a table or like a document that is usually kind of a nested lists and maps sort of thing, or in JavaScript terms, nested objects and arrays. So there's which is a little bit more similar to an object database in a way. It just allows storing multiple objects in a single document, as opposed to a typical object database where they'd be separate. And object databases often end up looking more like a graph database in how they're implemented. And if you want to take an object model and translate it directly into a persistable data structure, a graph database isn't a bad way to go for that. And that actually gets into another topic, though, of kind of the general idea of an object sort of data structure and a relational data structure. And then in the application logic side of things, or in that little part of the world, you're typically dealing with more of an object, like an in-memory data structure, where like graph references are incredibly efficient. But you don't have that sort of luxury in persistent data stores typically, but graph databases try to make that sort of object reference lookup extremely efficient, so that you can like pull down a whole graph of objects and then do things with them. But interestingly, like in business applications, that kind of data is not as useful, because one of the great things about a relational database is a human can just go look at the data and use very generic tools for querying and wandering around the data, exploring it, if you will, or writing very specific queries to get different things out of that data. With object databases, it's never so convenient. It's a real chore as a human to look through a list of JSON documents, for example, and try to pick out like the first name in each document, or try to pick out the order number in each document, compared to in a table sort of like a tabular structure. It's way more cumbersome for a human to do. For a machine, it doesn't matter as much, but if everything's in a tabular structure, it makes it very easy for humans to do stuff with it. And that makes it a lot easier to write other things outside of an application that look at the data, like reporting tools and such. So there are other reasons why relational data structures are very useful. But there are different applications and different types of data needs for different things. So that isn't to say that relational databases are the best for everything. Although one thing that people have noticed in certain open source databases and commercial databases, but Postgres is a great example of an open source database that has really taken a lot of these NoSQL ideas and incorporated them into the relational database. So that so you can do a lot of things that are very similar to what you could in some of the different flavors of modern NoSQL databases, like searching within JSON documents, for example, and full text searches and some of that sort of thing. Moqui doesn't use a lot of these right now because we try to remain database agnostic. But it is an interesting concept that maybe we could even possibly replace a lot of what Elasticsearch does, or what Elasticsearch or OpenSearch now is used for in Moqui, and use some of the stuff in Postgres instead, if you're running on Postgres anyway. Doing everything we do with Elasticsearch there would be a lot more difficult, because there are some pretty elaborate things that Elasticsearch does with aggregations and being able to build basically the results needed for multiple parts of a report, or for multiple reports in a single pass through the data and stuff like that. So I know there's quite a bit that's very particular that then you'd have to research to see if you can really replace it. But as in terms of general concepts and technology and so on, there's a lot that you can do in relational databases that a few years ago you could only do in NoSQL databases, or only efficiently. I mean, obviously you can make a tool, like you can come up with so many different solutions for problems that you can stretch a tool like a relational database to do all sorts of things. But yeah.
Right. One thing that that I think we should address is how so like when creating a business application, or I guess most applications in general,
Mhm.
why do you need a database, and what is this interaction between the programmer and the program and a database?
I guess the general need for a database just comes down to you want some place to persist data, some place to keep track of things. Um, and and there are, countless options and tools for those options across all sorts of different programming languages for all sorts of different ways to save data. Um, whether it be in memory or on disk, but typically when we're talking about persistence, then we'll use kind of disk-oriented structures or structures that are meant to be persisted or persistent, I should say, and easily accessible and so on. So so that it's a basic part of any application, managing data. And when you get into enterprise software, that's really about all the software does is it manages data. And for most enterprise applications, that is mostly structured data. Obviously, there are enterprise applications that deal with unstructured or semi-structured data, like large documents, like Word types of documents, like human readable, human written documents. Um, so there's obviously a lot of different types of data that different sorts of applications can get into. Like some applications will deal with a lot of image data, while others not really so much, or some deal with a lot of large text data. Whereas a typical enterprise application that's running on a relational database deals with lots of small bits of text. Um, but yeah, either way, storing data is a fundamental part of any application, and most applications, when you look at them, they're all you really do when you're interacting with them is change data somewhere. Um, and it's like even if the application comes and goes, those data changes they remain. Um, and so they have kind of a nature and a life cycle that is separate from the application. Um, then I guess for a programmer, a person interacting with these, I'm not quite sure what you meant by that part of the question.
Well, I guess what is a what are some of the ways that a programmer takes this idea of manipulating data, which is really like what you said, that's all a program really does, and how do you make it so that it is efficient for a programmer to do that? Because programmers are expensive, and if there's someone making a business application, then they want to maximize their developers' productivity, and at developers, they want to be productive as much as the business does. So how does this this developer interaction between uh, the program and the database, like what are some of the different models that are typically used to have this interaction?
Sure. I guess you can look at it as like this kind of gets into the space of low code and no code sorts of tool sets. Whether it's for data or for other things that you do commonly, like accessing, querying or writing data, um, that is a big part of any application. Of course, there are many other parts, many other things that go on. User interfaces often get way more complex, for example, than data structures and how they're persisted and so on, at least in the amount of code that needs to be written. Um, and the number of things you want to have control over, and so on. And how much control you want to have over something really is a big part of developer efficiency. So if there are things that you do very frequently and you only have so many variations on those things, you don't need a whole lot of control. You can define in advance what's going to be done and then just kind of stick with that. And that gets it. So no code and low code sorts of frameworks will basically look at those things, what is done commonly, and try to create some easy way to do those things so that when you're writing software, it requires as little code as possible to get the different interactions with data, for example, on the kind of the database side of things. So you can do the interactions you want with the data in as little code as possible, and also, preferably as error-free as possible, and all of these sorts of things. So low code is just basically looking at stuff you do a lot and then designing and building some tools to make that easier to do. No code kind of takes that one step further, although it's the same thing and the same sort of concept, and tries to simplify the options and operations that are available down to something that can just be interacted with in a user interface, like a WYSIWYG screen editor or a query builder or something like that. So which options are
What is a
available?
WYSIWYG screen editor?
So WYSIWYG is in what you see is what you get. So like you would have in that term actually originally came about for word processors, because early word processors like WordPerfect, you could create very elaborate, very nice looking document layouts and do all sorts of fonts and positioning and so on, and images and whatnot. But while you're editing the document, you couldn't see those on the screens. The technology for that sort of user interface just wasn't there. So most of what people interact with in editors these days is WYSIWYG. So you're actually seeing as you go what the thing really looks like, and what the result will really look like. And along the way, as you're making changes, you're interacting with something that looks pretty similar to the result that you want to end up with. So for like a screen editor, that means that everything you can do on a screen is some kind of little option you can select, something you can drag around or pop up a form and select things from drop downs or whatever. So it's kind of like not necessarily the furthest extent of where low code can get to, but no code is really basically just saying we're going to use configuration for everything instead of code. If you look at something like Moqui, it's more intentionally low code than no code, although you could use it in a no code sort of tool. But it is but there are all sorts of accommodations to allow for expressions in a scripting language, or plugging in little scripts, or plugging in your like the actual HTML text you want to be dumped out, or like on the user interface side of things, and a lot of these kind of extension points or flexibility points, if you will. So yeah.
Right. So what is an example? So is the entity engine, or the entity facade in Moqui, is that considered a low code way to access a database?
I don't know who owns the term low code these days. It'd probably be Gartner or someone like that, if anybody. But but I would consider any tool that allows you to reduce the amount of code that you are writing by providing higher level components for common things would be a low code, like a low code tool. And Moqui as a framework is very much intended for that, to reduce the amount of code you have to write, and turn a lot of it into configuration instead of code. So like instead of writing code for managing transactions, there's a lot you can do by just using the transaction settings in a service definition, and splitting your code across multiple services is needed to get the transactional behavior you want. And then the result is of using that sort of approach is that you have nice little chunks of separate logic in different services that are made to succeed or fail together, or whatever else the transactions are being used for. And so that's kind of the main concept with low code, is just reducing the amount of code. And then so Moqui would be, I think, qualifies very well as a low code tool. And in a manner of speaking, a lot of Moqui is also no code, because you can do a lot with configuration in XML files. Yes, not like a WYSIWYG editor. So it's kind of like the WordPerfect sort of user interface for doing that. But a lot of it, I think, fits into the no code definition as well, where you're selecting from a bunch of pre-built options using configuration. And that's true for XML screens, or even down to like XML actions and services and such. Although those smell a lot more like code than any of the other XML configurations in Moqui. The XML actions too.
Right. So I guess this kind of no code principle is a layer of abstraction in technology, which is common for lots of different things. But for example, there is this thing called machine code that every computer and that every computer really understands, every processor understands, but to actually make it so that a programmer can understand it well, not like a normal person, but a very a programmer who knows a lot, to understand all of that stuff. It's not really necessary to perform a function that the programmer needs to do. Like, the programmer has this thing that they need to do, and they don't want to worry about the underlying technology to take that code and convert it into something a computer can understand. They just write this code in a more high level way, and then there's this other program called a compiler to then take that code and convert it into something that a computer can understand. So is this kind of the same idea? Is that it's another layer of abstraction on this technology stack?
Yeah, that's a good term to use, a layer of abstraction. And in a way, so like when working on enterprise applications, there are various layers of abstraction that you deal with. Some of them are standardized, and some of them, like with well-defined standards, but not always well implemented and followed standards. And others are for de facto standards, or like, that's the way it was built and that's the way it is until something, there's some major issue with it, then everyone needs to agree on how it's going to change, or someone's going to change it, and then everyone just kind of goes along with it. Kind of making a new de facto standard. So, but yeah, layers of abstraction. I mean, so you think about, like we were talking about earlier with alternatives for building things, you can, for a given like application, like or a screen in application, like a search screen, we could have that search box, the data from that search box sent to Elasticsearch for finding results, or the database for finding results, or something very primitive like scanning through files, or something for to get the results. So so there are lots of different ways of dealing with things, but each of the different ways of doing it, basically you're looking at sort of a higher level of abstraction, and the general goal is to find the tool that fits best. So over time, what really happens a lot more with software development and software developers is that your experience and body of knowledge is not so important in how you can write like a bug-free method in a class. You know, that's sort of a prerequisite, but your efficiency and how much you can do really comes down to your toolbox, like how much your toolbox can do and how familiar you are with it. So if you want to do something like manipulating an image, you know, one of your considerations might be just write it yourself and deal with the you know, byte array in memory or something. But more likely, you're just going to find a library that can do the image manipulations you want and use that. So you're going to use this layer of abstraction, like a higher layer of abstraction, um, and take advantage of pre-built code that has that is designed to do certain things and has an interface that you can use to do that much more easily than writing lower level code to do it yourself. And that's true with compilers too. So like a for loop, there's not like an instruction for a for loop in machine code. That's implemented using a number of different machine instructions for different parts of that for loop structure. And in fact, there are a bunch of different machine instructions that that go into play for that. So for like the condition checking and for like go to for different parts of the generated program, so it can repeat the code in the loop and all that kind of stuff. So there's yeah, so there's so it is, but it is a good way to think about it. I think like layers of abstraction and using the appropriate layer of abstraction for the work you need to do, and only drop down to lower layers of abstraction as needed. And then the first step for writing any sort of complex software is finding tools that are where the layer of abstraction is as high as possible, but they still do what you want or what you need.
Right. Yeah, it's a difficult balance.
Yeah.
So I guess with this low code idea and this layer of abstraction, how does the entity facade manage these more basic operations with database that are the most common? But how does it eliminate code? Which is really the big idea with low code, and how does that help the developer? I guess like more of how does it how does the abstraction work, I guess is the idea of like how does this program make it so that I can type in this configuration and it figures out what to do from there?
Yeah. So for this like particular abstraction of an interface that makes it easier to work with a relational database, and especially easier for a developer or people involved with writing and maintaining code to work with it. There are a few different activities, if you will, that developers do that are really important. So one of them is defining the data model. So defining the tables or entities and the fields or columns. And taking into account that those will change over time. Some changes are very common, others not so much. And some of the uncommon ones can be worked around and are in fact better to be worked around. So for example, it's very common to add a table or add a column to a table, or rather add an entity or add a field to an entity. Less common to change the primary key of an entity, change the composition of the primary key, adding a field to it, or changing a multi-key, like a natural primary key, into a sequenced, just an internal reference sort of primary key.
What is a primary key? And I guess what, like,
sure.
why would
So
changing it be?
Yeah, so a table having multiple columns, primary key basically just says these are the columns that together identify a distinct record in the table. So each record, each row in the table needs to have a distinct key for it, and those combinations of columns, it can be just one column, but make up the distinct reference for that record. So as an example, sometimes you define, so you've got a table with, say, 6 columns, and you start with 2 of them being the primary key, and then realize that, oh, sometimes we want multiple records where this third one varies, and we want to be able to support that. So then we need to add that column to the primary key. And that's a kind of a problem for the various reasons, but like if you tried to add that as a primary key, but there are records that don't have that value, then what do you do? Because typically the idea of the primary key field is null is not a valid value. But obviously there are ways to work around that. It's just common in relational databases. So so there a lot of these sorts of database operations there can be problems with, but one of the ideas with designing a layer of abstraction is you want to well, any layer of abstraction is going to encourage certain practices and discourage other practices. So sometimes it's more accidental than on purpose when designing a framework or a tool set that provides a higher layer of abstraction. But it is a good thing to consider, like, how will people use this and what will they do with it, and what kind of mess will it turn into. So for example, the idea of changing the primary key columns on a database table, it's often a better practice to just create an entirely new table and then migrate the data from there. So and then that also keeps the number of operations simpler. You might have to do more operations because you have to do a table create, and then you have to do the migrate of the data and so on. But you do more simple operations instead of the single more complex operation of updating something like updating foreign key. So in the tool set, like when defining an entity that will basically represent a database table, then it is something to consider. Like, do we want to make it easy to do this or that? And that's one where Moqui does not have tools built in to try to make it easy to change the primary key on a table, because it's kind of an inherently unsafe thing to do. That it's likely to have problems if you just try to do it on the fly in a production database, and that could even include certain types of data corruption problems when you're modifying database metadata, or data loss problems. So so in the tool set, basically we just keep it simple and recommend things like, if you're going to change the primary key, it's better to define a new entity with a different name and then deprecate the old one. And then another nice thing about that is you can build tools for using the entity facade itself for migrating data between the two tables. Whereas if you had different versions of an entity definition over time, framework at runtime, unless we kind of built something in to do this, doesn't know what changed between a current entity definition and the last one and such. So
right.
So yeah, so that but those are a lot of the challenges, is not just taking all these tools, but kind of also reducing it to a practice, or in the tool design, kind of encouraging certain practices over others. And it's so when you get into higher and higher layers of abstraction, you're going to have more and more bias towards a certain objective, like that's inevitable, up to the ultimate layer of abstraction, which is like the actual application that you're building and people are interacting with. That's kind of the highest layer of abstraction. And then, you know, there it's very explicit, like you have to make all these choices along the way. So you have to bias in some way or other. You might make certain choices that leave some flexibility open, intentionally or unintentionally. You kind of hope that flexibility is what you need at some point in the future when some crazy variation or requirement comes up. But yeah, for the most part, basically, it comes down to looking at what needs to be done a lot and making some more efficient ways to do it. And as often as developers hate to hear it, or if there's something that hasn't really been reduced to practice, if you will, like we're not very familiar with it, then I encourage people not to build tools too early. Like do it manually a bunch of times. Actually, you know, write the code, and then you'll have a much better idea of what the tool needs to do and what it can, how it can make things easier.
Right, like the first person who made a hammer used lots of rocks before they designed a hammer, right? Like they like they used this rock as a hammer, and it's not quite as good as this, because if you try to assume what the function of something is before you actually know what it is, then you're not going to make something that does the thing that you expect it to, because the thing that you expect it to is not defined well enough.
Yeah. And for the hammer analogy, it might be that, yeah, I guess you're thinking of, okay, the objective is to pound things in some way, maybe force something into something else, like a nail into wood, or to break something or whatever. And yeah, so I guess that's where the example of the rock versus a hammer comes in, is you can use rocks to pound on things, but it's not the best tool. You don't get a whole lot of leverage without any sort of handle on the rock. So then you can improve the tool. But one way or another, it's a little bit funny, I guess, with a simple tool like that sort of abstraction, where it's not like it has configurable parameters, like at least not on the fly configurable parameters. If you think about the concept of a hammer, there's a lot that you can vary, like the length of the handle or the shaft on the hammer, the weight of the head, the shape of the head. I mean, you shape it one way, and the hammer is now called an axe. Or maybe it's that on one side and the hammer on the other, and so on. So but yeah, it comes down to the objective of that you're building for, and when the objective you're building for comes to improving developer efficiency, you have to know a lot about what the developers actually do in order to improve on that in an effective way. So, which kind of, you know, with the entity facade, the very early versions of it, I started by looking at what other technology was out there and what other people were doing for persistence. And this was the days of like object relational mapping tools like Hibernate were around, but Hibernate itself was not.
What is object relational mapping?
So object relational mapping is kind of a general term for tools that basically take relational database data structures and operations and map them to an object model and object operations, so that you can, what it tries to do is help you pretend that the relational database is an object database. So that basically, as you create a graph of objects and say persist them, then the persistence layer just knows how to do that and drop it into database tables, the relational database tables. And early on, as I was looking at some of those tools, you know, it's an interesting concept to be able to do that. And there are a lot of people that were there's been a lot of research over time into the idea of object databases and their translation layers to put an object database sort of on top of a relational database, and a lot of those are interesting concepts, but I think they really miss the point and the power of relational databases, and that you have a simple way of structuring a large number of small bits of data that people can easily understand, from developers to end users, and or it's sufficiently simple that people can understand it, which is not true of all persistent structures. And then you take that simplicity and you throw it away by trying to make it look to the developer like an object database, but only sort of, because you still have to deal with the fact that it is a relational database and it is remotely persisted. And so there are certain methods you have to call now and then that, are along those lines. It's not really like an object database where you're dealing with graphs of objects, and whether it's in memory or persisted is even somewhat transparent to you as a developer, like the really like a full I don't know, like a fully featured object database. So it still doesn't approach that sort of experience, but so it's not as good as that, and yet it also isn't as good as dealing with it as a relational data structure, because it tries to incorporate a bunch of these concepts from object-based data structures, which is a bit more like a document database. So it creates kind of a weird translation layer, but it does fill the general need, the idea that there are a bunch of options we need to do in the database, or operations we need to do in the database, and we want a simple way to do them. So that's it is one way to go about approaching that problem with an object relational mapping sort of tool. So some of the early there were some early ones around commercial before open source for the ORM types of tools, and the term ORM was used quite a bit in the early 2000s, not so much anymore, but in fact, it's in a way, persistence in Java, for example, has gone so far in that direction of kind of the object relational mapping that part of the reason the term has been lost is because there's nothing to distinguish it from. That's what almost everyone uses all the time. So it's like some sort of an object relational mapping tool, and attempting to have an object model that they can interact with in software that then represents the relational model that's in the database.
And I guess, what are some of the effects of this object model? Can you have an object model and still have it be quote unquote no code, or is that just not a thing?
Well, you could, yeah. You just wouldn't necessarily have as much flexibility with it. I mean, if you were to do that, then there are going to be things in the tools for dealing explicitly with objects as opposed to dealing with relational tables. So actually, if you look at the typical no-code tool, they might even use some object relational mapping tools internally, like Hibernate and such. But what they're exposing to the end user is the relational table. So they actually try to make it more transparent, as opposed to this idea with object relational mapping of hiding the complexities of the database behind an object model.
So what they're doing is they're taking a relational database and converting it into an object model, and then converting it back into a more relational way to actually expose it to an API.
No, I wouldn't think so. No, I mean, they could, but I kind of doubt they would do that. They'll keep their metadata about so if you've got a no-code tool where you're building a screen that looks at table, like a find order screen or something, where the results displayed are order records of some sort, then in the tool, it would basically typically just have an option for adding like adding a data source of some sort. Like you configure the database you want, and then the tool goes and looks at those database table definitions. And then in the user interface, it can fill in, okay, which table do you want it to come from? Or they'll often have some kind of query builder tool, which is like, which the results of which are usually like an entity, a view entity in the OFBiz entity engine or the Moqui Entity Facade. And their
But
little
like
query
an
builder.
SQL view, right?
Yeah, kind of like an SQL view, but it'll allow them to define joins and certain, like, you know, built-in conditions that are always applied in addition to whatever conditions are applied at query time and so on. So they'll usually have something that's fairly similar to a view entity where you can configure that sort of thing. And the and then you can use that as the table, if you will, or the view that you're going to be displaying in a table on a screen. So they'll usually stick with that level. All the configuration is that level. I mean, I suppose one could try to have the configuration be in there limited to what is in an object model, but or to try to generate code on the fly for handling all those things. But typically with a no-code tool, the user is interacting with the database. That's what they're familiar with, and you know, they know, well, they need to know, like, if you're going to be getting data from a database, you need to know which table's it in, and that's not a huge bar to get over. So there are lots of non-developers who can handle that just fine. Like lots of business users who can, like more advanced, especially business users or more technical business users, that can handle that just fine. But they won't know about, like, okay, what some kind of crazy object model that someone designed, and then to try to hide the database and all this kind of stuff. Though that's I don't think it's a very pragmatic thing for people to do in general. And the fact that we do it as programmers is a little bit silly, but it is kind of the industry norm.
Right.
Yeah.
Yeah. If you're taking this idea and you're converting it, specifically like one for programmers and one for business people at like a technological level, then it makes it much more difficult for the programmers to talk with the business people, right? Because like it's a completely different thing. Like it's just different, and so and it may be converted into something for each of them, but like it's more of a communication thing.
Yeah.
I mean, it's both a communication thing and a technological thing, where it makes it hard to talk about the technological part of it because it's so complicated, or making it more complicated than it really needs to be.
Often so, yeah. I mean, it's a good example of what is, in my opinion, a swing and a miss in terms of an abstraction, and points out a danger in defining abstractions. So okay, so part of the idea of writing an abstraction is you don't need to know about what's on the other side. Or in software, that's a common part of an idea of an abstraction. But in the practical reality of software, that rarely happens. You almost always need to know about what's on the other side, or you need to know someone and have quick access, like easy, consistent access to that person who knows about what's on the other side. And I'm thinking there are scenarios like, you know, splitting up team responsibilities and that kind of thing. Like if you don't know what's on the other side and you don't even have the code for what's on the other side, then, you know, it's hard to do a whole lot with it. At that point, you're hacking, you're not developing. Or you have to hack for a while before the development can start.
Right.
Or before you're going to make any substantial progress on development. But so like this idea that an abstraction layer for a database needs to hide the nature of the database and how data is structured is just sort of, I think, I mean, this is kind of one of the philosophies that drove the design of the entity engine and the entity facade, is not trying to abandon the relational data structures and the concept of relational data structures in the abstraction. We want that carried all the way through, even all the way to the user interface in many cases. And this actually goes back to requirements of business applications that are increasingly common, where people are more technical, they're more familiar with computers, they've been exposed to them their entire life, and they've done all sorts of different things with them as part of school and work and hobbies and recreation and so on. So people don't necessarily want things hidden so much. I mean, there's still a lot of like details that we want hidden. Even as developers, there are a lot of details we want hidden. Like most of the time when we're writing code, we don't want to worry about every little bit flip in the database. We just, want to use our tools to get this certain thing done, this certain thing built. And
yeah, you just want it to work. You don't care about how it's done. And I mean, from a business level, it's the same idea. Like, you want this programmer to get this to work, and you don't care how they do it. So if it's just get it to work all the way down, then that can make it very productive.
Yeah. Or how they do it, the extent of your care is kind of limited to, can they do it efficiently? Can they maintain it over time? Can they, is it, if another programmer comes along, are they going to be able to do something with it? All these sorts of things. So,
right.
Yeah. But yeah, the exact tools used, I mean, there are pragmatic concerns and there are architectural consideration. Like, this is where I see the kind of higher form of architecture is deciding on the tools to use, and that's often a difficult thing if your tools are inflexible or you can't do much with them. So that's one of the great things about open source tools, because when you come to a bind where the tool doesn't do what you need it to, then you have the ultimate workaround of modifying the source. Whereas without that, you might have to rewrite what the tool is doing just in order to tweak one little parameter. So, or to tweak one little bit of behavior that's buried in code somewhere. So, so I mean, with open source things, we can get away with a lot that you can't get away with in commercial applications. But commercial applications also often don't get away with it as much as they think they do, and things are very limited and people can't do what they need to. So, but anyway, like being aware of what's on the other side of an abstraction, like that's not, it's this whole idea of trying to hide that. Even some people think of it as intentionally trying to obfuscate things. Like, you'll see this philosophy come up, this kind of misapplied idea of having multiple layers, of having to keep them separate and use separate concepts or something. So like, name one thing one way in the database, and then in the object model for it, they'll name it something else, because that's the point, is we want to hide what's behind that object. We want everyone to interact with the object and not even know what's in the database. But in reality, that kind of abstraction is just not very helpful, not very effective. So that's one of the big issues that comes up a lot with ORM tools, is people will treat it as if it were just some efficient graph persistence of an object model, but it is not that underneath, and so they can write things that are incredibly inefficient. And I've seen some examples of that in larger scale ORM-based systems, like enterprise systems, where the the number of n+1 queries it was doing, for example, is just crazy because the programmers weren't even aware that it was doing an n+1 query. They just called a
What do you
method on a
mean by
class.
an n+1 query?
Yeah, that deserves some explanation. So it's a very common problem with databases is like, or a very common sort of structure behind the problem first is you'll have something like like two tables like order header and order item. And you want a table that represents things that apply to the entire order, but then you also have multiple items on the order, like different products, and you want different things to only apply to each item. So you need different tables. Or you could combine them into one and have a bunch of redundant data across them, but that's another topic. So
Yeah,
um,
like the idea between normalized and denormalized data structures,
denormalized.
right?
Yeah. So especially in a denormalized data structures, you can end up with a lot of n+1 query sorts of problems where we want not just the like we want to search for all of the products, like we want to have a report that gets all of the products that were purchased in a certain month and their quantities. Well, for that, we've got the date of each order on the order header, but the product used in the quantity is on the order item. And so an n+1 query would basically query all the order headers that are within that range. And then for each order header, query all the order items to see if they have see which products they have and in which quantities. So so the n query, the n+1 means instead of doing one big query, you do one big query, and then for each result, you do for n number of results, you do an additional query. So that's why it's called n+1.
And the reason why people care about it is because of performance, right? Like if you just have an n query, then it's much more performant than an n+1 query.
Or
right?
just a one query would be the way to put that. Yeah.
Right. Yep.
So yeah, so if you just have one query instead of doing the one query plus n queries or one query per result of the original query, then yeah, it's way more efficient. Fewer round trips to the database, and that kind of latency causes a lot of problems. And these kind of problems they're not just problems for people waiting. They're also like a person waiting for like when they click on a button for the next screen or page to show up. It's also a problem because it's making code wait. So like when you're doing transactional things, well, okay, so let's talk about why n+1 can make things so much slower, and that is, so say you're, especially for a report, that's kind of a a case where it would be really bad to do this, but this happens. Like sometimes people will build such things. So like for all of the orders in a month, okay, if you have a very low volume of orders and you only have 100 of them for that month, and it's not a big deal to individually run 100 queries to see what's going on, it'll still take some time, and you might have something like a 1 millisecond round trip to the database. But so each of those 100 plus the one query, you're going to take a millisecond each, but that's still only a tenth of a second. It's not a big deal for a single user. But if you have a million orders, well, then it's a problem. So the one problem with n+1 thing is they don't scale well. They scale really poorly. So as you have more data, things slow down dramatically. And then another problem is just the time it takes to do it. So one way or another, the computers are going to have to do all that work. Like the database is going to have to look up, like internally the database, if you're doing a join, does n+1 queries. So they, they find the records on like the order header, and then for each of those, they go find the records on the order items. Or they might go the other way around, like so what a query optimizer would do a big query on all the order items, and then look up the order header for each. And typically it'll do that and put it in a temporary table and then do whatever filtering or sorting you want on it and all of that sort of thing. But all of that happens on the database side, where the round trip is basically just from the CPU to the disk, and doesn't have to go all the way over the network, which is not just an electrical signal going over the network. There's serialization on one side and deserialization on the other side. There's all sorts of back and forth and so on that adds a lot of overhead. But the biggest killer is in terms of latency. So if you're locking a table and you do some kind of operation, if you're locking a table row, so locking a record, and you're doing some kind of an operation, it's rare to lock a table and best to avoid. But locking a single record even, or locking a number of records across various tables, which is common for a lot of more complex operations, if your logic takes a long time to run, those locks are being held a lot longer, and other things are going to have to sit and wait a lot longer. And that just becomes a compounding problem and can really bring a system to its knees, and then you end up with more and more queries queued up. They're waiting for locks, and they're waiting for all sorts of different locks, and the database is figuring out what to do with them. So they're, anyway, it can cause an incredible number of problems with those kind of bottlenecks. And there are problems that you can't solve by upgrading the hardware. Like, okay, now we've gone from having a million different transactions sitting there pending, waiting for this lock instead of 100, but you still have this problem, so many transactions waiting for these locks and stuff. So, yeah.
Right.
Oh, and I bring that up as an example because that's the sort of thing that when it gets too bad, like with one client, they had a very large, so large that they wouldn't even tell me how big the server was. They had some information concerns and whatnot too, but they had a very large Oracle database, and they actually managed to get it to crash. And crashing Oracle is supposed to be impossible. So, but they had a pool of like 100 different and actually no, I think they got up a lot bigger than that. I think it was closer to more like 1,000 different like 1,000 physical application servers that were hammering on this database. And a lot of their scaling of application servers were because of these latency problems. So they needed a lot more servers to just sit there under low CPU load, but just sitting there waiting for the database to do stuff.
Yeah, that's not a good situation.
Yeah. So not that you have to, like, it's not that you can't write queries with joins using an ORM tool. It's just the nature of it does not, or it is one side of things that gets obfuscated a little bit, and then developers don't think as much about.
Right.
Because like chaining method calls, it's easy. Thinking of each one of those method calls as a database operation, and inside especially like multiple layers of nested loops or something as each doing database operations, developers often don't think of that.
Right. Yeah. If you're going to have a tool that is this important to the normal operation of, especially like a business, then you want to make sure that tool makes it so that whatever that tool helps with, so this tool specifically is to help developers to deal with data. You want to make it so that it's easy for the developers to write code that is not slow. You want to help developers write fast code, and I guess that's another layer, another reason for the traditional object relational mapping model to, it's kind of where it falls on its knees is in like real production systems. Like developers need to think about these things because they have performance implications.
Yeah, and it's amazing how fast computers are. So which is really nice about it. It's one of the reasons that developers can be so much more efficient these days, because most of the time you don't have to worry about performance very much. But occasionally it'll bite you, and occasionally you'll have multiple things that kind of combine together to cause really big performance problems, and then suddenly it's like it's not a performance problem, it's a system stability problem, and it's like this thing won't even run like with the 10,000 people accessing it at the same time that we need, because that's how many people are in our call center, and it goes down and they can't do anything. So yeah. So there, and again, it's like, I don't know, it's not maybe the best distinction between ORM technology, like that as an example is not maybe the most important thing, but it is something that comes up as a practice that is encouraged by the tool, as opposed to like enabled and encouraged by the tool that is not a very good practice, versus a tool that is in some ways a little bit more work to use. It can actually be a little bit more code than an ORM tool, but that's mainly because you are using a small set of simple operations to do your things, as opposed to a whole bunch of methods that could be doing whatever underneath. But those methods actually have to be implemented, whereas with the entity facade or the OFBiz entity engine, those methods always have the same behavior regardless of which entity you're dealing with. And they'll have variations in behavior based on the entity definition, like, you know, going over multiple fields, or different data types for fields, or, you know, things like that. But they really always behave the same. So you get a lot more consistency than you will with many ORM tools, where you have custom methods that do find operations and such. And it's a lot more explicit in the code. You don't have to trace it. You don't have to hop into another method to see exactly what it's doing. So yeah, which is fine if your abstraction is well defined, but it's easy to get lazy with abstractions, and ORM is just full of kind of gotchas where it's easy to get lazy with abstractions.
Yeah, makes a lot of sense.
Yeah. That wasn't the main reason I decided against it, though.
All right. What like why did you decide not to use a traditional ORM?
So back in the day, when, like in the early versions of OFBiz, it actually used a code generation approach and generated, so had entity definition files that were just a small variation on what was at the time called a container managed persistence enterprise Java bean, because they
That's a
couldn't
mouthful.
come up with a shorter name. Actually, the problem with the naming came from, okay, we're going to create this big standard in Java called an enterprise Java bean, and then we're going to have multiple types. They're all called enterprise Java beans, but there's an entity bean, and there's a service bean, and there's some other ones. And for entity beans, you can have container managed persistence, where it basically behaves like an ORM tool, or you can write your own persistent stuff. And I don't remember what they called that. So anyway, like, you get these variations on things. And so the name of each thing is like specifying all of the variations or specifying enough so that you know which variation exactly you're talking about. So it's an entity EJB designed for container managed persistence. And for those, they had XML files for defining the entities. So basically started with those. Like, it's easy to parse an XML file, and this is data we can work with to generate code. And so that was kind of what the first version of the OFBiz persistent stuff did. Code generation has a lot of problems, especially for maintenance over time. And either you don't touch the code that was generated so you can regenerate it, or you use fancy blocks and stuff, like comment blocks around things, or the generated code will add automatic comments that says like insert code here, or don't touch anything over here, or all that kind of stuff to try to get it to go. But it's a big mess. And tools these days do a lot better with that, even with container managed persistence back in the day with container managed entity EJBs. There was still a fair amount of code you had to write. And so it was more than you have to do for like modern ORM tools like Hibernate, which use annotations. So basically all the data about the data model, if you will, that the tool needs to know to build queries, like to write the SQL, to create tables, to do queries on them, and so on. All of that is in annotations. So that does reduce the number of files and simplify things a bit. But back in the day, you had like for each database table, you had to add a section to an XML file, and then you had like 3 other different files to do. Plus, we wanted some other things, like we wanted generic screens to be able to look at the data in these things. So we'll generate a whole bunch of screens. And and in the end, yeah, I think let's see, I think the first version of OFBiz that had the code generation tool and kind of the initial data model based on the data model resource book. I think it had, I don't know, 300 or 400 entities, something like that. And it generated about 1 million lines of code. So, and not only did it take a little while to generate, but when you're starting up, like these old Java application servers were also not super fast in loading data and classes and so on. So having 400 container managed EJBs also took a long time to start up for these old application servers.
What's an EJB? You may have said that.
Oh yeah, Enterprise Java Bean. I think I did mention that before, but it's and the Enterprise Java Bean was just like an extension, like some actual standards that Sun Microsystems worked on and others that they collaborated with, but including folks at like Oracle and WebLogic and some of the big players back in the day of application servers. But I don't know, it's just a name. It was kind of an extension of the idea of a Java Bean, which is more of a pattern than a standard, if you will, but like all the getters and setters, those kind of methods, that kind of idea is basically a Java Bean.
So like would a bean have a setter and a getter?
Yeah, so unless it's like a read-only property, then it'd only have a getter. And you can design write-only things too, that those don't come up as often, but where you'd only have a setter.
It's just like a thing that you can configure on whether it can change or not. And you can also change things or just read them.
Yeah, so it's kind of a pseudo standard in Java that was so more like a pattern, like a recommended pattern that has become very much a standard in a lot of ways. Like the idea of getters and setters wasn't a common thing before the idea before the Java being sort of definition around that. I mean, it was common enough, but it wasn't like today where everyone knows exactly what you mean when you say getters and setters. And if they think about it a little bit, they'll even know that basically the getters and setters on an object are for treating the object like data and knowing which data is available inside that object. So like in theory, you could write methods that are named anything you want that access data in the object or mutate data in the object, but naming them get and set. So having getters and setters is just it's a nice convention to do that. And then there was some tooling built around that too, so that like in Groovy, for example, if I have an object called truck and it has a method on it called it has a field on it called number of tires, then it would have a method called get number of tires. Well, if I just do like truck dot number of tires, Groovy will figure out, oh, that matches a get method on the class, so we'll call the get method to do that.
Right.
So those kind of patterns have become sort of, well, I guess very standardized over time, if you will, or just very common, like a pseudo standard. But, yeah, so that's really all a Java bean is about, is an object that represents some kind of data. Using it for services is a little bit funny, like having a service Java bean, because service represents a unit of work, represents logic. It's kind of, but anyway, that's what happens with names. So,
Yeah, so I guess you're talking a bit about the reasons why like the whole Java idea of an ORM is, I guess, why taking these principles and applying it to a no-code tool is very, it's difficult, and you're kind of going through some of the iterations like code generation.
Right. Okay. Yeah, I can continue from there too. Yeah, kind of the evolution of the tool. So starting with code generation, yeah, and seeing that sort of mess, then the objective was, how do we reduce the amount of code, or even better, just not have any code. And so, and I was looking at it, that's kind of what it came down to. I was working on a contract at the time where they had a very different sort of architecture and some very different sort of ideas about how to build tools and what they should use internally. And by the way, before the like open source stuff was around then, but it's nothing like today where you've just got library, especially in a very common language like Java, you've got libraries for just about anything you can imagine. It's I don't know, easily 1,000 to 1, and probably more like 10 or 100,000 to 1 in terms of the number of libraries available these days versus like the early 2000s in open source, and then and commercially too. But yeah, there's just been an incredible explosion of stuff available out there. Some of it's even useful. So so anyway, but on that project, basically we were writing value objects. So they weren't using enterprise Java beans or anything for persistence, but they were doing basically a roll your own object relational mapping. So you'd write your own classes that represented a database table, and then you would write different methods on it to do different operations, like different types of finds, and to I don't think they did in that shop, I don't think they did any of the database metadata in there. They did that separately. They just had like .sql files sitting around. So as you'd work on the class, you go maintain the .sql file. So it's kind of the most primitive approach, like almost no tooling available except JDBC. Just the Java library for talking to the database, sending queries over and getting results back and stuff. So anyway, as part of that, though, it was interesting to experience that sort of thing. It ran a lot better than EJBs, that's for sure. Like the performance is way better. I think EJBs were designed so that Sun Microsystems could sell more hardware. That's one of the problems with having a hardware company designing software tools.
That is certainly a conflict of interest.
Yeah. And it was so bad that it was not an uncommon joke around then. Like, but anyway, so working on these, basically, that was the opportunity that I had to get down and do it manually for a while, and then eventually see, well, why don't we take these manually rolled entity value objects and create a generic one that can work with any entity definition, because you look at a bunch of these classes that are defined to handle persistence, And they all follow pretty similar patterns. And having a bunch of them, you have a lot of annoyances like, oh, we want all find operations to do this automatically. Well, now I have to go change all the find operations across all these different classes. And that's still a problem with ORM tools. They'll generate, like have automatic logic for a lot of find operations, but they're typically pretty limited compared to even like the entity find in Moqui. So and the automatically generated ones don't do anything like joins and whatnot, which is one of the reasons why you end up with people doing a lot of N+1 queries, because they don't write other methods to add to these classes or to put somewhere else. Like, and then when you have an operation that operates on multiple tables, where do you put it? You don't, if you've got one class per table, you need a separate place to put those, or separate classes that represent the joins, or, you know, these sorts of things end up kind of exploding. So the so I mean, you can kind of see, like, they can all be done. It's just, you can kind of see why people end up doing N+1 things, because it's easier with what the tool does automatically. So anyway, yeah, that was kind of the general idea, is we take a value object and write one that behaves differently based on the definition of the entity. And then all it needs to know when it is initialized is the name of the entity. And then you can, you know, then it has like a generic get method, generic set method, where you pass in the field name instead of having a predefined method for each field. So with that approach, basically, we don't need anything for persistence except the when you're actually using the tool and working with it, you don't need to define anything in advance for persistence except the entity definition. And that's basically just the configuration thing.
In other tools, why would you need to declare to like do that?
Why would you need to define like do more than just an entity definition?
Yep.
Mainly because you need an object, or at least an interface, for each entity. And with modern ORM tools, you don't have an XML entity definition at all. That goes into annotations in the interface or class that you're defining for to represent the entity. So it's, but then, like with the old tools, you had to do both. You had to define the classes or the interfaces, or both, even with container managed EJVs, even though there were certain interfaces you didn't have to define because the container automatically implemented them. It's kind of the idea. But and that's what ORM tools do these days with annotations, is they just that's how things are. Like a find method is implemented, is just by an annotation that tells it that it's this type of find and it should do these sorts of things. Or that's one way to implement find methods anyway. So yeah, so that, but one of the reasons that they'll do that, and one of the reasons why this type of generic value object is seen as a non-starter for developers, is because they want or basically kind of going with the object purist concept of everything as an object is kind of part of the idea, but also everything that you do with any data in code needs to have a compiler like linked reference to whatever it's referring to. So that the compiler itself at compile time can tell you if you're referring to a wrong field name or a wrong entity name. Because if the class name is wrong, if the class doesn't exist, then the name is wrong. Or if the method doesn't exist, the getter or setter methods don't exist for a field, then the field name is wrong. And the compiler can pick that up because it has all of those classes and methods defined. Whereas with the generic value one, it can't do that. It can't tell you when you've got a field name wrong. We can only tell you that at runtime. So that's the big downside to using something like a generic value object. And it's seen as, you know, something that introduces more errors, and it can introduce more errors in code. I think developers are pretty good at getting strings right, or they get good at it over time.
Because if you don't, then it doesn't work.
Yeah, if you don't, you get a whole bunch of errors. So, and it can be nice for things like autocomplete tools and whatnot, whereas typically, like working with the entity facade, I'll have something separate open that is a reference for the entity. And that could be, we could get around that with IDE plugins and that sort of thing, but those don't exist right now. So
yeah, I mean, with that logic, you just make a tool that will be able to make it so that those things are possible. Because I mean,
yeah,
there are already tools for most of these frameworks, anyways. And so, because there's some specific thing that it does that makes it so that it's nice for developers. So it's really just a tooling problem, right? So like,
yeah. And at the ground level, it's even a tooling problem. It's like, if you want all of your bugs to be discovered at compile time, then you know, that's versus runtime, then, or at least, and obviously you can't have all your bugs discovered at compile time, otherwise, you know, we wouldn't have bugs, but in compiled software. But but at least for these like certain types of bugs, like misspellings or whatever,
yeah,
you can the tool basically, it's when it can catch it. And it is nice to be able to catch errors when you're compiling code versus when you run it. It's kind of closer to the developer, if you will. But if a developer is not running their code, then we have another issue. So if you really believe in test-driven development or test-first development, or at least you have, you know, decent test processes and a strong mandate for testing, then it's not so much of an issue, because runtime will be part of your development process, and so you'll catch it at runtime.
right.
Yeah. But still, yeah, I mean, it is a trade-off, and I guess the consensus is so universal that it's not worth the trade-off that most people don't even consider an alternative. But I think this is true not just for database interactions, by the way. I think this is true for services, where people write objects that represent web services as opposed to something like an XML service definition in Moqui or OFBiz. And basically, I mean, it's a general philosophy of we just write objects for everything, and we do object whatever mapping for everything. So we do object service mapping, and we do object relational mapping, instead of the different idea of having tools that are designed for these specific things, and you don't have to write objects for them. We just have the tools for them, and you can use those tools in your code. So instead of doing object relational mapping, we have tools that make it easier to work with a relational data model in your application, in your code, and in your user interfaces. And you can take advantage of a lot of like bulk operations and automated things because of that. So yeah, so there's a very different philosophy there, and even like on the service level with object service mappings and stuff, when everything internally is defined as a service, like in Moqui, when you define a structure for a REST API with you know, resources and IDs and so on to make up in a path to make up endpoints. So how you design that tree of resources and IDs for a REST API can vary, but each endpoint in the REST API, it just maps to a service definition in Moqui, because the concept of a service definition in Moqui is very similar to the concept of like a REST service. So the conceptual match is much better there, and all we have to do in the configuration file for the REST API is say, call this service. And then the tools know, okay, this service takes these input parameters, has these output parameters, it has requires authentication or not. It all this kind of stuff is in the service definition, so we don't have to repeat it in a REST API endpoint definition.
Right.
And then we have those tools to use internally as well. And organizing logic by services, I think, is for business logic anyway, is a huge improvement over organizing them in classes.
Yeah, isn't that because it's like more natural to think about it that way? Because if you think about it like a class is a complicated structure with initialization and like with construction and destruction and all this stuff. But if you're thinking about logic, then you just want to think about the specific things that happen, and you don't want to think about the other things. The same principles of abstraction. You just want to think about the one thing that you're thinking about.
Yeah.
Yeah. I guess does that match? Does that make sense?
Yeah, it makes sense, and kind of gets back to what we were talking about with the abstraction layers. If they hide or obfuscate too much of what's underneath, then they can actually be more difficult to use and require more work to use than if they're more transparent or literal, if you will, like like when you want to do something, when you want to define it, like build a screen, then you use a screen definition. Like it's that is part of the idea of defining or designing like low code and no code tools, is what are all the things we want to create, and then we create like artifacts to configure those specific things. And and that's what the end result looks like, is those artifacts. So, yeah.
Right.
And then if it's, the more literal it is for a person, the easier it is for them to conceptually map to it and use it.
This idea of code generation is interesting. So I guess if you want to have a no code tool, or sorry, like a low code tool, where you really just want to define the behavior, and no code is just you're defining you're still defining the behavior, but you're doing that through a GUI rather than through a text interface is really the difference, just to make it easier for the person that is actually interacting with it.
Right.
But this idea of code generation at compile time versus, because I mean, if you want to have as little code as possible, then your source code is not the actual code that is run. It is not the end result of what you want to do. The end result of what you want to do is define somewhere, and then I guess there's two main approaches where you can either generate the code, which, like you said, has problems with maintenance, and if you generate code and you ever change it, then why generate the code in the first place? It's if there's something that you need to change, then change the generation of that code rather than the actual code. But this other idea is, and I guess so, this generation of code at compile time versus and actually generate the code that actually runs the actual logic versus defining it somewhere and then looking at that definition and then running it at runtime is that kind of are those kind of the two main ways to approach low code and no code?
So with the Moqui approach, It doesn't. Well, okay. So some of it, like the XML actions, it does generate code for those at runtime because those get converted to a Groovy script, and then that Groovy script gets compiled at runtime. And I mean, it gets compiled into a script that then gets run with Groovy scripts. They're basically just kind of on-the-fly Java objects that represent them. With entity operations or with database operations, it doesn't actually generate any code per class or anything like that. It just basically has code that behaves differently based on the definition of the entity. So there's just one set of code for all entities. And it behaves differently so that we don't need different code for different entities.
And so and code, when you're running it, is typically in memory. And so the difference is between, and I guess like when you're actually running it, you'll call the code, and the code is in memory. But I guess in this scenario, you have the code that's defined, which is in memory, just like the other model. But in this scenario, you have the configuration in memory to access it very quickly. And so it's the same idea. You still have the actual the information. If you think about it from an information standpoint, you still have the information in memory. It's just in like a data form versus a code form.
Yes. Yeah. Yeah. I think that's correct. Yeah. That is one way to look at it. Yes. So it's and really code is data, but in this case, or sorry, I mean, code itself is data, and it gets turned into other data to execute and all that.
Right.
But in this case, what we're defining, what we're specifying is different. Like we're not specifying code that runs, just a configuration that tells code how to behave. Yeah. And by the way, for the most part, part of the reason this idea works well for persistence is there's not a lot of variation in what code does for persistence. It also has an effect that turns out to be sort of important, where application logic can get buried in persistence classes, and it is nice to have those separated. And then obviously using a service-oriented architecture internally will separate out logic code, but it makes it not even having that option to do that at the persistence layer makes it much more explicit or much more clear when you're tracing through things.
Right. Yeah, because that way everything is kind of just it's all kind of self-contained and loosely coupled, to borrow some microservice buzzwords.
Yeah, the loose coupling is kind of an interesting part of it, and it also goes back to like the checking for misspellings and such at compile time. One of the problems with the idea of checking for such things at compile time is you have to have for a given entity class, you have to have the name of the table somewhere, and that's going to be in text. So like if there's a misspelling on that, you get the same sort of error. Like you can only get a runtime error. It's in a separate system. There's an abstraction layer that cannot have like compile time references or anything like that. So so no matter what you do, there's still a layer of that. And in fact, I mean, you could write like little objects that wrap around the entity facade if you wanted that. And people have done that. I've seen a number of people do that sort of thing. If they get more elaborate, they'll build something that allows them to define an interface, and then based on the interface definition will automatically do things. Like the interface will have an automatic implementation, in other words. So you still instantiate a generic class, but it implements these interfaces on the fly. And Java has some kind of funky stuff to do that. So it's still possible with the tool. It's just generally discouraged because it adds another thing that needs to be maintained, and it doesn't, in my opinion, ultimately add enough value to be worth even that bit of extra code, like defining an interface for each entity.
Yeah.
And then some will take a different approach where, like with strings, sometimes people will think this rule of magic values applies to all strings, and so they'll create big constants files for all strings. And you could do that for entity and field names and stuff. But also, in my opinion, I think those are a bad practice and not a good way to work.
What's the benefit of doing that?
The benefit of doing that is you get some compile time checking on the code, as long as the like the file that has all the static strings in it, or however you're representing these things, is correct, then other code that uses it will be correct. And of course, it has the right value in there, and for the string desired. But there are a few disadvantages to that, and one of them is maintenance becomes a pain, and especially when you have hundreds of entities and thousands of fields. It's a lot of strings there, so it's easy to get the wrong string, as much as it's easy to misspell a string. And then you also end up often getting multiple static fields that are for a given string value. And so when you're searching code, like maintaining or debugging things, you want to know everywhere an entity is used. If you search for the entity name, that'll get you one stat, but then you have to find all of the different static fields that reference that entity name, and then you have to search for those too. So so overall, I think that sort of approach creates more problems than it solves, and it takes a fair amount of work to define all those. Not a lot of work, but it's still a fair amount. Especially if you're starting cold. I mean, you could write some code to generate, write something to generate the code, or generate the static strings file.
Right.
But I guess that goes back to another philosophy where if there's code you're writing that could be handled by a generator, then you could probably improve the tools.
Right.
So you could probably use an abstraction layer that instead of a code generator.
Yeah, and I guess the problem with the abstraction layers is that you can either have them so like, I guess the idea with an abstraction is you have this, you describe the functionality and you don't worry about actually running that, but at some point you have to run it, because I mean otherwise the definition is pointless. And so you can either decide to run that, you can either decide to turn that definition into runnable stuff at compile time or at runtime. And
yeah, or decide on the behavior like at compile time, or with a code generator, kind of a pre-compile step. But yeah,
right. And so it like, is there an inherent flaw to taking that actual convert the definition into something runnable? Is there a flaw of doing that at compile time, or is that just like Moqui decided not to do that? because it was easier or for whatever reason.
You mean like with the entity facade?
It could be the entity facade, or it could be the the actions stuff, where like behavior is defined, but then to actually run it, code is generated.
Yeah. I mean, in a way, like with the XML actions, they're just a script, and it's just a convenience for doing certain very common things. And so you don't have to write the individual Groovy for each of those things. Like you don't have to write the Groovy for each of those individual things. So it's kind of a special case. It's kind of its own special little thing when it comes to the world of tools.
Right.
With the entity facade, it's I mean, the goal is to have an API that offers generic behavior so that you don't have to have anything you don't have to have any sort of code per entity, at least for persistence. So
Right.
so it kind of
like a way to define.
It kind of sidesteps the problem instead of trying to solve it.
Right. Yeah. With the entity engine, it does do that. But like with the XML actions, I guess that's kind of that kind of gets more to that abstraction.
And with any script that is that's not compiled, like it's not compiled as part of a whole, that doesn't have hard linking or anything. It's got or compile time linking. It's all runtime linking. So like in a Groovy script, when you access a class or a method on a class or something like that, in a Groovy script that is, so you can write Groovy classes that are compiled and compiled at the same time as other Java files and kind of follow the same, semantics and process. But with a Groovy script, it's basically just a bunch of text until it gets compiled at runtime. When it does get compiled at runtime into a class, it still uses a lot of like the Java object metadata to access things. It doesn't build in like hard linked method calls and stuff like a compiler would. So there are some interesting differences there, but what it comes down to from a developer experience and so on, and for maintenance over time, is it's not something that you run, or sorry, it's not something that you compile along with everything else. You can update it and modify it, which can be nice. So you don't have to worry about restarting or playing games with class loader to load updated classes on the fly or anything like that. And it's and then so I guess it makes it easier to update and stuff. But the main difference is that these are scripts and not classes. They're not things that get instantiated except to run the script.
Right.
The code is very much just code. It's not a data structure in any way. So yeah. So I mean, as far as like I don't know how much there is a distinction though between like when the information is used to get behavior as there is in where that information lives and what that information looks like and stuff. I think that's the more important distinction, because in theory everything in Moqui could be used for code generation and and run in very different ways. But yeah, it would. So the more important thing is kind of what it allows you to do, and how much work it takes to do it.
Right. That makes sense.
Yeah, but a lot of this, I don't know, a lot of what I prefer and recommend about development and stuff is, especially for business logic and business software, is a bit counter to common object-oriented practices and principles. Um, because, for example, I think also linear code is far more valuable than short code, if that makes sense. So, say if
What
you
do you
have
mean
a
by
lot.
linear code?
Yeah, so say you have a really long, like a method that needs to do a bunch of stuff, like it's exporting data to a file. So it needs to do a bunch of queries, it needs to do kind of a bunch of combining or splitting of the data or whatever, restructuring of the data for the file format. And then it needs to actually write out the file. Um, so what you see a lot with object-oriented developers or developers that are kind of trained in object-oriented programming and have heard all these things like don't have any methods longer than 20 lines or you know, whatever kind of number gets picked out of the air, is they'll go about writing these sorts of things very differently. So if you're thinking of it as like from a script perspective, you usually do more linear code. If you're thinking of it from an object perspective, okay, you might have one main method that does things, but it's going to call these other three methods. It's going to call one that does the data preparation and one that like, or does all the data querying. There's one that does the data restructuring, and then there's another one that writes out the file. And then the top level method just calls those threes. It doesn't do anything else. And then in the one that's gathering the data, they're doing a bunch of these like entity find operations, and they realize, or they start thinking, huh, there's like 2 lines of code for that entity find operation. I could make my big thing smaller by turning into that into 1 line of code by wrapping in a method. And then, you know, they get a little further down and it's like, oh, this one little thing that we want to do a lot in these files, and I'll write a separate little method to do that. Or this method's getting really long, so I'm just going to take this code block out and stick it in another method, and you know, pass in the parameters or use object fields or whatever to pass the data around. And then you know, you get all of these kind of things going on and all this kind of thinking, as opposed to just write the whole thing out. If you're going to optimize the code in terms of how it's structured and whatnot, you know, maybe consider doing that after the fact. But problem with a lot of this like kind of object-oriented design stuff where you think everything needs to be a well-structured object, even just like a big long script to dump some data, is yeah, you end up splitting it all over the place. And then when like debugging that code and trying to track down exactly what it does or even understand what it does, if each of those method calls becomes an abstraction, and if it's a good one, then maybe it will make the code better and more readable. But often they're not, and you have to go look at the methods. But when debugging, you have to go look at those methods anyway, you know, to make sure it's doing what is expected, or so that you understand exactly what it's doing. Because if you misunderstand that, you might not realize that there's a problem further down. So getting the big picture kind of loaded into your head is really difficult when it's split into, you know, 20 different places, possibly across multiple files, instead of just inline in one big script. So so that's what I mean by very linear programming, instead of being like fragmented and split across a bunch of different methods and classes and so on.
I see. Yeah, and I guess the reason that why Moqui does linear programming rather than the other alternative.
Well, I mean, in Moqui itself, whatever's done there is just the decision of the developer who did it. But when you're using like a service-oriented architecture, kind of a service structure internally for modeling logic, your logic ends up being a lot more script-like anyway. And so so, you know, splitting it into, if it really needs to be something very separate, then split it into a different service. But you think about things in terms of like units of work that make sense together. and that's how the code is organized into those units of work that make sense together, as opposed to trying to just reuse everything. It's kind of like this idea that every query is precious and should be put somewhere that you can reuse it, which I don't believe in at all. Like, it's easy to write queries. Like, it's easy to write these find calls. And so, and often you will have small variations on those find calls, and yeah, maybe 90% of the code is the same, but it doesn't matter. I mean, in each context, you're specifying just what you need for that context. There's not a lot of extra redundancy there that you can abstract out. So when people do things like putting those into little methods to do individual find operations, they become a lot of really dumb methods that cause problems for maintenance and understanding the code, instead of the whole, one of the big ideas behind deduplication, which is, reducing the number of errors, increasing the consistency of code, and that sort of thing. So yeah.
Right. And I guess a big part of that is if you define what you need for every given context and you try to use it in a different context, then you're really going to need to change it anyways. And so rather than being so I guess like you really do want to copy and paste there when you're doing changes based off of the context, and having code that is reused in different contexts it determines what the context is, and sometimes you don't want that to happen, if that makes sense.
Yeah, or it can be something that actually causes issues because you think it does a certain thing, but it's slightly different. And then maybe the slightly different thing you do, you go add a parameter for that thing, but then everything else that's using that has to be changed to handle that other parameter. Or, these little, I don't know, these games just kind of end up going in circles. And like, reuse is a good concept, but reuse always adds complexity, and not just complexity in writing the software, but in maintaining it and being aware of where things are reused, and the impact that small changes might have when on a bunch of things, or the testing scope that the testing scope can explode with reuse done poorly. These kind of things get
right.
Start to become more issues. Yeah. Or
A
bigger
little bit of redundancy simplifies things drastically, I think is kind of what we're coming to.
Yeah. And it's also a pragmatic, or I guess I could say it's important to be pragmatic about how you look at redundancy, because just because there's a lot of code doesn't mean there's a lot of redundancy in the code. And trying to abstract things out when there's not a lot of redundancy just kind of makes a mess of fragmented code instead of one code block. Maybe some people think it's offensive to see, like a 200-line code block, but when you think of it in terms of scripts and, logic that kind of operates as a set, and, refactor is needed if you want to reuse something, the code's all sitting there. And if you write things in a well-organized linear way, it's pretty easy to identify which block of code does this thing, and then it's not too hard to abstract out if you need to, or if it makes sense to, and it's going to add value. But a lot of developers with object-oriented programming especially kind of do that in advance. It's kind of like trying to preemptively optimize everything you write, and then you just get it wrong because abstractions and structuring things is hard.
Yeah, and to be fair to the people who like object-oriented programming, most of the Moqui framework is written in an object-oriented way. Like it's not a problem with object-oriented programming. It's a problem with object-oriented programming inside of business logic, I think, is kind of what we're coming down to. And a lot of these tools, what they allow you to do is, like, the tools are built in that they may be like currently the Moqui framework is built in an object-oriented way, but the actual logic of it, like the structure of the code should meet the should meet the requirement of what it is meant to do. For business logic, you can define a bit. You can like business logic. It can be defined and is often defined in something like a Word document, and a Word document that has lots of different. It may have lots of different instructions, but they're usually formatted in paragraphs. And if you're taking this, paragraphs are like or like closely coupled stuff. Like this is one thing that the business needs to do. This is another thing that the business needs to do, and actually taking that and transferring it into code. If you try to transfer it into an object-oriented mindset, then it doesn't transfer one-to-one, right? Like it's like you have to take this and you have to interpolate on how do I take this and how do I make it object-oriented. It's a lot easier computationally for a human to take this, or even for a computer to take this idea and convert it into code if it's a one-to-one mapping.
Yeah, if you don't have like conceptual mismatches or things like that to deal with. Yeah.
Yep.
Well, that might be a good place to leave this conversation. I don't know. Was there anything else you wanted to talk about?
I don't think so. I think that this was fantastic. I think that we really got a lot of like a lot of theory, a lot of architecture, and I think that this really helped to explain really the idea and history behind this entity engine and kind of the idea of Moqui in general. And this no-code idea actually applied in real life to and having a way for it to be productive for both business people and developers, and kind of all these requirements, and to do it in a really elegant way. And I think that is really where Moqui shines, is this really impressive combination of lots of common things to create an application and turning that into something that's easy to pick up for a developer. So thank you for the work that you've done, and thank you for sharing it with the world.
Well, that's great. Yeah, thanks, Michael. That's very generous. It's it's the sort of thing that goes through hundreds of revisions from hundreds of people looking at it, and that naturally takes a long time to evolve because it's complex enough that no one person could do it, even like in isolation, even understanding all the things that that might be useful, or the problems people run into and actual use, or all of these sorts of things. So
Yeah.
but it is fascinating to see a lot of the concepts, like in a no-code system. There are a lot of similar concepts in Moqui. In a service-oriented architecture, there are a lot of similar concepts in Moqui and used internally. So I don't know, as the best ideas in the software industry shake out over time, it's neat to see a lot of these ideas become more prominent, even if not, used internally like they are in Moqui, or even if not quite in the same way and such. So, but great, yeah. I don't know. Thanks for the interview and opportunity to chat over some of this. And
yeah, of course. Thanks for being available and all that stuff.